started right away, right? Wasn't it mostly just starting off with solving triangles?
Yeah.
Okay. So number 6. The missing angle was, I think, 36. What else do you have? You have little b being 12.14. Hopefully you did 3 decimals, but whatever, you know the book, they usually do 2. And then little a was 8.82. Number 22. Solving for the missing side, the function, or I should say the trait that you should have used, the way it was given would have just been tangent. Then solve by multiplying h is 81.2. Number next one. Oops, too much. Number 34. This is the one that we started on yesterday, right?
Yeah.
So when you go ahead and solve, 5,099. I don't think we got this second one. I mean, we set it up, but I don't think we finished solving. Remember, we had the t that we were solving for. We knew the speed, but we needed the time. And so solve. They went ahead and rearranged, multiply up and divide 117.7. Number 40. Ooh, it was a bearing one. Check the picture if they didn't give it to you. Check the picture if they didn't give it to you. You might have gotten a little bit off because you were supposed to use arctangent to get the little baby angle. But the bearing from north would have had to go all that direction, or I guess you could have also written it. It depends on what they said. Did they say compass bearing? Anybody have their book? Number 40, or you should have written it in directions. What kind of angle did they ask for? Ooh, they just said bearing. There's 2 different ways of writing bearing. And if they don't give you like a north, south, east, west, it's always north star. It's always from north. So if you had done something like, ooh, what would that have been? 38? No, not 38, 28. If you had said south 28 west, you're technically right. If you had said south 28 west, you're technically right. But they went ahead and said that since they were just saying the word bearing, they weren't asking for the different directions. You could have gone also from north, and that's what they did. Or like in some of the other word problems where they just said a bearing and they didn't give you like the north, south, east, west. They meant from north, turning clockwise. That's why they added 180. So then 208.
How did you know you used arctan?
Oh, I mean, you could have done this angle down here and used arctan, but long story short, you didn't know the hypotenuse. So you could have done Pythagorean to find it, and then done sine and cosine. Since the hypotenuse was missing opposite adjacent, tangent's the kind of natural one. Number 42 is another word problem, I think. But you can see the math they used to solve it. Oh, this was the fire in the 2 towers. It was hard. I think I actually have some work shown on this one. Let's come back to 42. Did anybody else think 42 was hard? Okay, hold on. Let me get to my notes. I think from a previous year, I have someone's work from the board. Was this one 42? Yeah. Okay, so let's check it out. Oh, it's my work. Look, it's my writing. That's not. That's right. They didn't know how to do it. So we have the 2 towers. And then we have the fire out here. They gave us this angle is 76 and that angle is 56. Are those the 2 things they gave you?
Yeah.
So you could have done the inside just from subtracting by 90, right? That's not a big deal. And you end up with 18 and then 33. You could have solved like kind of parallel lines and figured out that one's 76 and that one's 56. So we could have found the angles. The problem is they were asking about the sides. They told us the entire distance is 30, so what I did is I put one of the sides of the triangle as x, and I made the other one as
Y.
Oh, I guess I kept the line. One of them is y, and I made the other one 30 minus y. You just want to make a variable for one, and then 30 take away that one is the other one. You could have done it with x, you could have done it with y. Either way. Then I went ahead and said, okay, this D is in common. So if I make a tangent with opposite and adjacent using this guy, and if I do tangent with opposite and adjacent using that guy, I'll have 2 different equations, both missing D and both missing Y. With 2 equations, 2 unknowns, substitution, you can go ahead and solve. So then I went ahead and solved both of them for d by multiplying. For d by multiplying, set the d's equal to each other, which is how I got this expression. Then the name of the game is basically get the y terms on one side, so you can factor out the y, and then divide. And you end up with y is equal to 30 tangent 14 over tangent 14 plus tangent 34. A little bit messy. But we kind of, I don't know, I think this one's similar to, we did one like this. Was it with the plane in the sky and the two towns? Remember that one? The pilots looking at the two towns and we had to like set up multiple variables and put it all together. I think it was similar to that one, kind of.
No, this one.
But this one is a little bit harder because they gave you the full length and you had to kind of make this, set one variable, make the other one the 30 minus that variable. But ultimately you wanted to use, after solving for your angles, use tangent, because then you'll have y's and d's in both. Solve for the same variables, set them equal to, solve. So if you guys want to write down any of that, or if you want to take a picture of it, that's not a bad idea. If you want to reference it later. But I think you guys can get it. There was no class last period, so then it wasn't like it didn't get warm, so now it's just kind of looking weird. But once you guys are in here a while, it'll turn on right before you leave, and the next class will be freezing. Is that our last even? 42? Oh, I didn't even give you like 52, the wavy one? Oh, you guys, I didn't give you any my motion. I'm so sad. I'm sure that you're really disappointed. So 42 was the last problem, the last one?
Yep.
Huh. I like the buoy one on number 52 if you guys look at it, just because it shows a buoy and then it shows the. I don't think you have any simple harmonic motion specifically on the test. Any word problems probably come from triangle problems, just in case you want to know. Victor.
I mean, I have like a general
Or
question.
Kevin. Why am I saying Victor? I was looking at you and then I. Kevin.
I have like a general question.
Yeah.
For like triangles, would C usually be the hypotenuse?
If they're labeling it usually, just be aware if there's like more than one triangle, they might have to have one hypotenuse be one thing and another be another thing.
Like the sense, like here is the C is 15.
Oh, interesting. Which one?
Number 6.
Okay, I'm gonna move the picture. My book isn't looking for. The dilemma is on those ones, I know they do say right triangles. I mean, according to the pictures, it said 5 through 14 seems to be the hypotenuse. If they didn't give you a picture, technically, that would be a dangerous assumption to make. That's why I don't say C is always, because they could just label it weird. But because of their picture that they gave you, yeah, it was like below the problems. Any other questions on homework? Yeah,
Number.
Alright.
For 34,
Okay. The one that we were working on yesterday?
yeah, I wanted to know why is 60,500 not the why is it the hypotenuse and not like one of the other sides?
Okay, I didn't memorize the numbers to that. I just remember our work that we did yesterday, so hold on. Number 34, 16. Oh, it's all about the picture. So when they're talking about the airplane, it was taking off because it had an angle of ascent. So here's the plane actually flying. Here's where it's flying off, like the airport where it took off from. And here's our altitude. They give this angle, the angle of ascent is 18 degrees. And when you're trying to figure out how far the plane has gone by taking its speed and multiplying it by the 60 seconds or the 1 minute that it's gone, the 16,500, the plane is flying in this line. It's going up to the clouds and beyond, right? Like, so this is the 16,500. And so you just have to take the triangle as it's given. The altitude is where the 90-degree angle is. So that's going to be the opposite from the angle of ascent. And the 16,500, it's not how far it's gone horizontally, it's how far it's gone in the air diagonally. Does that make sense? So that's why we have opposite being the altitude and then hypotenuse. Okay. Any other questions from here? Colby, was your question about something else you want to ask? Besides,
It was about Christmas music.
Oh. it's a very good question. Let's wait until we talk about tests a little bit. All right, cool kids. If you want, go ahead and grab out somewhere so you're gonna write down a few topics from the test. I mean, the calculator portion, I don't think that you guys necessarily have much to write down besides be ready for solving triangles, for word problems. I don't think the calculator portion should necessarily be. I mean, the problems might be hard, but as far as like something to write down to study, it's more like we go over the examples that we did, get some more examples in your review, see how they go, ask questions hopefully before we're done today. If you guys ever want to, if you're like the review is always hard at the end and I always get stuck, you could work backwards, I suppose. My TAs would grade backwards the same way they grade forward. So if you haven't started it, if you were afraid of those word problems at the end, maybe work backwards today so you can ask me questions. But let's talk about the non-calculator portion for a bit, okay? Non-calculator portion from section 4.1. You might want to, for the non-calculator, you might want to study how to convert radians to degrees or vice versa. Radians to degrees or backwards. There were some like funny formulas in section 4.1. I think the only one you need to really stress about is area of a sector. Area of a sector. And also let's do the radian formula, which is theta equals arc length over radius. Is that right? Sorry, I always remember it this way. S equals arc theta, which means theta equals, as long as you have one of them, whether the arc length one or whether the radian one. Either one will work. One variation of those. But there are other formulas having to do with like the linear speed and the angular speed. Don't worry about those. Don't worry about those. Section 4.2, know the unit circle in some way, shape, or form. Section 4.2. Know the unit circle in some way, shape, or form. Remember, non-calculated part. And know how to find each of your trig functions, whether it's with SOHCAHTOA, whether it's with x's and y's, like y over x is tangent, x over y is cotangent. Know some way of thinking about all of your trig functions from a triangle. Section 4.3. That's where we had that table of identities. So you're going to want to study over those formulas. Like, for instance, tangent, the quotient property tangent is sine over cosine. There's that table in section 4.3 of the identities. That'd be good to look at. You had some more word problems, blah, 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 blah. Section 4.4, reference angles. Might be something you should probably look over. And then last but not least, I'm just going to group them together. 4, 5, 4, 6, know how to graph your trig functions. There is going to be, I'm not sure if there's one or two. Let's just say two. I'm going to ask you at least 2 long answer trig graphs to make. I can promise you one's going to be a sine or cosine. One's going to be a sine or cosine. And if I give you a sine or cosine, I'll probably somehow bring in cosecant, secant because they just bounce off. So I'm going to give you a sine or cosine, probably a secant or cosecant to go along with it. But I could also give you, for the second one, I could also give you a tangent or cotangent. So you've got to review how to graph your sines, cosines, tangents, cotangents, secants, and cosecants. At sections 4, 5, and 4, 6. Don't worry about the damped functions. Remember how we would multiply a trig by something else and have it like isolated. Don't worry about those. Section 4.7, as far as non-calculator, know how to do the unit circle backwards. What if I was to ask you something like, for instance, cosine inverse of negative root 3 over 2. Can you get me the one principal value? No. 1/2 is sine at that time. I need an angle. That's a ratio.
Oh, 60.
No. 60 is a positive cosine. And that's cosine's 1/2. That's not going to help.
340.
No, not 240. That's way out of. That's in the fourth quadrant. Cosine would still be. Oh no, that'd be third quadrant. Cosine would be negative, but I need the one principal value. 150. It would be 150, or another way of writing it, it would be 5 pi over 6. That is the one principal value. Now, hold on. Cosine. How did we get to 150? Well, first of all, you had to think unit circle, and you had to realize that at 30 degrees is when cosine is root 3 over 2. It could have been from a table, that could have been from memorization, that could have been from over a lot. You had to figure out at 30 degrees cosine is root 3 over 2, but question, I don't want positive, I want negative. So I can't stay in this quadrant. Now some of you guys are trying to get to the fourth quadrant, I think, by going a negative angle, but cosine's still positive. All students take calculus. Cosine's positive here and here. Where is it negative? Here. Which one am I looking for if I have to remember that cosine inverse, like the other inverses, has been cut down? Something to study. You gotta remember your restrictions. Cosine, it just goes naturally. If it goes to the first quadrant, it also goes to the second. It wouldn't randomly jump over to the third. Cosine inverse goes between the angles of 0 and pi, or 0 and 180. That's your everybody knows. Sine inverse goes between negative pi over 2 and pi over 2. Once you figure out the second quadrant is where I want to look, then say, what's the 30-degree one in the second quadrant? And the answer is 150. Or in radians, 5 pi over 6. Anyway, good example of a non-calculator inverse question that you might face. And then 4.8 is going to be calculator. It's going to be, can you set up a triangle? Can you set up your sine, cosine, tangent, and solve? There might be one word problem similar to the airplane in the 2 cities, similar to the 2 towers and the fire. There might be one word problem where you have to put together 2 different triangles in order to solve for your variables. Okay? Besides that, can I give you one hint about your calculator? Can anybody, if I'm talking about inverse trait, section 4.7, can anybody remember anything tricky as far as using your calculator for inverse trait?
If it's like secant or cosecant, then you have to do the inverse and then 1 over.
If I ask you for, let's just use cotangent inverse as an example. First of all, it's cotangent, so you're allowed to have 13. If it was sine or cosine inverse, only allowed to go to 1 and negative 1, that's it. Tangent and cotangent, they can go high, that's okay. But how would you plug this in your calculator? It's not unit circle, it's not square root of 3 over 3, 1 square root of 3. So, how do I get it? Good. You have to use tangent inverse, but where does the 1 over happen? On the inside. Alright, kids, if you did not write down the review from yesterday, I can get the problems up here on the board. Some of you weren't quite ready for that assignment. Let's get you into your review. Tomorrow, once again, remember, non-calculator part comes first. You're going to have to do the best you can to finish that, because you have to turn that part in before you get the calculator portion. There we go. If you guys need to borrow a book, come up and borrow a book if you have it with you, which would have been a smart thing to do. Just go ahead and get started. I am going to go ahead and ask Rebecca and anyone else that did get to work on it if they have any questions in just a moment. Don't get lost. Yeah, better do that. Here's the review for you guys to write down. Remember, reviews, no directions, no problems. Just get into it. And if you have any questions, as soon as the board's erased, I'll go ahead and write them down. 4.8, all the word problems, you're going to have your calculator. So my advice was to study, one of them was 4.8, the 2 towers and the fire problem. There's 2 triangles, but there was another one from earlier on. It was an example, it might be in our workspace, where we had the plane and the 2 cities. Yeah. It would just be 30 or pi over 6. Yeah. So So you just choose it from first instead of assign it.
Do you have to know complement, grade, and supplemental? Coterminal.
Yeah, I didn't specifically say it. It could be calculator, it could be non-calculator. If you guys want to add to your study sheet complementary, supplementary, coterminal, I was thinking maybe calculator, but I guess you're right, it could be non-calculator. And you still have to look at like 180s and 90s or pi's and pi over 2's and subtracting. That's a good question. Yeah.
Can I tutor something?
How much of your review do you have done? Then no. Do your review. Does anybody have any questions on the review that they want me to write down, look at, or? Anybody else who would start on the review yesterday? Might not have finished it, but did you start? Any questions on? You guys start? Okay. You guys can help each other. I'm just not giving any tutoring hours except for someone who has at least mostly attended the review. So if you haven't mostly attended it, I'm not sure you totally know if you totally understand it. But you still help by answering a question every now and then. It's not official. I'm going to freeze the screen in case you're still writing down problems. There was one question that we had to peek at.